Welcome back. It's Miss CG, and today we are going to talk about natural selection, how mutations can be beneficial and can help organisms, including people, better survive and adapt to their environment. So we're going to talk about also the peppered moth today. So if you go here to your June 1 through 4, or if you're period 8-9, you can also go, it goes up to the June 5th at the end of the week. Pay close attention if you're using my virtual classrooms that you're selecting the correct date and the correct period. So if you're period 2-3, today is June 2nd, so you should be looking for the date and your period. For my period 8-9, you're going to be doing this on June 3rd. So please make sure you select the correct one, since we have these day 1, day 2 classes. And again, if you want and you like it, you can still do the hyperlink, which will always be at the top here. Okay, so we'll take a look at both. Let's see here. This is going to be our June 2nd one. As soon as this loads, 3, 2, 1, load. Didn't work. Okay, let me hit present here. Here we go. Okay, so for our June 2nd, period 2, 3, and 5, 6, again, this will be June 3rd, and I'll say at the top, period 8-9. We're going to click on the TV and watch my walkthrough, which you're already doing, but just know for the future, that's where you can click that. Then you're going to watch video 1 on the bookshelf, Mutations in Natural Selection, short video. Then you're going to click on this cute little drum playing moth. I wonder how they got that moth to do that. Anyway, read the history of the peppered moth, and then there's a game at the end that you can play. It's really fun. You're a bird and you get to try to eat moths. Now, after you read this website and play the game, you are going to select the doc in your Google Classroom called Peppered Moth Simulation, and you're going to answer the 4 questions in that document. Okay, and then have fun clicking on all the other little links around here. All right. And if you just want to see the hyperlink version, it is slow. This one here, June 2nd for periods 2, 3, and 5, 6, June 3rd for period 8-9, all the same stuff. Okay. It's written here. My walkthrough will have a hyperlink as soon as I'm done recording it. Video, website, Google Doc. Okay. So let's get going. You're going to go over here to your classroom. You're going to be selecting the second one, Peppered Moth Simulation. Load the picture, you're taking a long time. And here it comes alive. Yeah. All right. Peppered moth. So we have 2 different colors. We have the dark peppered moth and the light peppered moth. Obviously, if you're looking at this picture, you're going to say, well, on this tree, the light colored peppered moth is going to be eaten first by a bird. But what if they're on a light colored tree? What if something happened to make those trees go from light to dark? So to have variation in a population, is a good thing, is a beneficial thing. Okay, so here's the website you're going to go to. And it's going to tell you the history of what happened. And the story starts in the 1800s during the Industrial Revolution. Okay, so you're going to click on this first one, Life Cycle of the Peppered Moth. You can go through this quickly, just see where it came from, England, Europe, North America. It tells you the size. It tells you all about the peppered moth. So you can read through this. Now, the trees that these moths lived on had lichen. And it was a light-colored lichen. And it really easily camouflaged these moths. But then our story, after you read all that, will take us into a naturalist who was studying these moths in the mid-1800s. During the Industrial Revolution, when factories were spewing out coal from their soots and covering all the trees with coal. I mean, it was everywhere in the cities. So now the trees went from a light color to a dark color. So then what happened? Who was easier to see and be eaten? The light colored moths, because now the trees were all dark. So if not for that variation of light colored and dark colored moths, this whole species would have become extinct. So that variation, which is caused by mutations, okay, was a beneficial mutation down the road because it helped this species to survive. Okay, so then you're going to go ahead and read on this next tab with the scientist here about some who the professor was who did the research and what the research was about. And then you're going to go here, bird's eye view. Okay, read about what the simulation is, the game that I'm talking about. Okay, and the purpose of the game. So now you'll get to this point. You're going to choose a forest for your experiment. So maybe you want to choose a light forest, dark forest, whatever it is. You can play both. You can go back and play both. Click on the site, and look, you're the bird. And you have to eat. I don't know if you can hear this, but the bird's making all kinds of crazy sounds. Okay? And you can see it's a light colored tree. So who am I going to see? As a bird, I'm going to see all the dark colored moths. Now on the bottom here, it's going to tell you what's going to happen to the population. You only get about a minute. Here's a timer at the corner to do this. And it shows you what's happening to the population over time. I mean, I can see that as it moves, but once it sits still, I'm really eating all those moths, okay? So have fun with that game. You could always go back out when you're done and play the light colored moth part, but then you go here and you're going to answer the 4 questions, okay, based on what you read and the game that you played. It's a fun game. What I want to talk to you about right now are different kinds of adaptations. And these adaptations, these changes in our populations have happened because of mutations in our genetics. Okay, so let's look at some examples of human adaptations first. People who live high up in the mountains, you don't have to read all this, but settlers from the Andes, okay, for example, people who live high in the Tibetan mountains, they have a special adaptation in their blood that actually allows them to survive in lower oxygen conditions. So let's go here to South America and Peru. So here, these beautiful, ruins from centuries ago are high up in the mountains. Now, as a visitor, we would go there and probably be huffing and puffing because it's so high up. You could see they're in the clouds up in here. But the people who lived here adapted. So this is an Incan site. Look at that. You can see high up again, all the view of the clouds. That's so beautiful. And this is located about 7,970 feet above sea level. And this is a restored village. But these people had to adapt to those higher level conditions. And how does that happen? There are mutations in the blood. Now, if you lived at a low elevation and you had an adaptation for your body being able to process oxygen more efficiently, you really wouldn't take notice because maybe you'll be a better runner than everybody else, but overall you wouldn't really take notice. Wouldn't benefit you unless you're doing a race with somebody, and it wouldn't hurt you. If you live high up in the mountains and you're born with a special adaptation to the special mutation to process oxygen more efficiently and not need as much oxygen, you would probably live to and survive and be more fit for your environment to pass on your genes. Now, if you pass on those genes because you're more fit and you can, I don't know, if 2 guys are battling over, I don't know, like that's how it happens with animals, but you obviously are a better provider. If you're a male, if you're a female, you're better at carrying, doing the labor that you have to do for gathering and hunting and getting the water and whatever different chores that the males and the females did. So you would live and be more well suited to reproducing. And then you would pass that trait on to your offspring, who then would be born, hopefully, with that mutation, and so on and so on. So now this mutation that was just in a couple of people at first now starts to spread and be carried out through the whole population. And then it becomes something that is like a dominant trait in the population. Okay. Let's go here, Tibet. Tibetans have also a similar trait. So this is the highest region on Earth with an average elevation of 4,900 meters high. Okay. So this is a Tibetan woman. These yaks are very, very important to the culture. It's not even that they eat them; they use their milk uh, for cheese, for all different kinds of things. So these animals are very important to them. Here's a Tibetan monastery way high up in the mountains. Okay, now let's go to Ethiopia. Ethiopia is 11,580 feet above sea level. Okay, so it says, yet despite living at elevations with low oxygen content, the Ethiopian highlanders are hardly hypoxic at all. It's meaning that they don't have issues with um, um, breathing. If we were to go there, and this may be a reason why we see a lot of long distance Ethiopian runners just surpassing everybody. Athletes will go to Ethiopia and train so that their bodies can try to adapt, even though it's not going to be in their DNA. But their lungs could get stronger by training at higher elevations. But some people, some cultures who have lived up in mountains for millennia, okay, have evolved this beneficial mutation of being able to process oxygen at lower levels. Okay, here's a picture of the Ethiopian plains. That's a really cool looking goat. It's like two-toned. And here is an Ethiopian child taking a picture way high up where they live. Okay, now let's talk about where we live, New Jersey. Our highest elevation is 1,800 feet above sea level. That's hardly anywhere near the other places. I guess that's 10,000 less. Don't worry about that. All right. So just imagine us going up there when we're barely at 2,000. All right. So another kind of beneficial mutation for humans is skin color. So what makes our skin a different color is this chemical called melanin. And it's basically a built-in sunblock. It protects our skin. It's from cancer, from the harmful rays of the sun. So think about if you lived, this is a map showing skin tone. And of course, we all evolved from Africa, and then over time we spread out. So this need for the higher levels of melanin decreased. But pretty much, in my opinion, we're all the same skin color, except for whether if you have more melanin in your skin, then you're darker. If you have less melanin in your skin, then you're lighter. But without that chemical, we're all the same color. So anyway, think about if you live close to the equator, you get all these direct beams of light on you. You're going to need a lot of skin protection. And, thousands of years ago, we didn't have sunblock. So you had to rely on your natural, what was given to you through genetics. So here's the kicker, though, with melanin. The more melanin you have in your skin, the less vitamin D you absorb from the sun. Now, vitamin D is necessary for survival. If you lack vitamin D, it could affect you to the point where you could get very sick and possibly die. So, you'll see orange juice and milk with vitamin D in it. But vitamin D is a vitamin that we get from the sun. Kind of cool. Kind of shows us how we're related to plants in a way, I guess. So anyway, if you live at the equator, you're getting tons of sun. So even though you have your dark, okay, and you are getting, not as much vitamin D, you're getting plenty because you're just getting hit by so much direct sun. Now, as you can see, as we spread out from the equator and move further up north and further down south, okay, you'll see that skin tone changes and it gets lighter. So the less direct sunlight you get, well, you don't need as much protection. So you don't need as much melanin. But the thing is, it's a good thing that happened. And the reason why this happened is also because, now remember we talked about vitamin D. If you don't get enough vitamin D, you're not going to live long enough to pass on your genes. So as people migrated out, they didn't need all that sun protection, all that melanin. So if you were lighter, you absorbed more vitamin D. Think about the people who live way up here in Norway and Finland. If they were dark, you get hardly any direct sunlight. So actually, it's not direct. It's very indirect. So you need to have light skin so that you can absorb enough vitamin D to survive. And besides which, you don't need the sunblock, the natural sunblock. So if some people were born with a mutation for lighter skin, well, that benefited them because they got more vitamins and they passed those genetics of lighter skin on to the next generation. And that's how came out with the skin tones. Closer to the equator, more sunblock, but you're still absorbing enough vitamin D. The further away you get, you don't need as much natural sunblock, but you need that vitamin D. So you got to be lighter. Okay, just mutations. And these were beneficial to people who lived further away from where we all came from naturally. All right, so there's a cool mutation with some Italians. And it was found that people would say in Italy, they live long. They hardly ever have heart attacks. What's going on? Well, it's due to a mutation, we found out. There is a mutation found in the people in a small town in Italy that protects them from the buildup of from their blood vessels being blocked by fats or by other things and being damaged. So people would say, whoa, they drink, wine, or they eat cheese and they eat these fatty things and they're still okay. Well, it's because of a mutation. How that mutation developed was by chance, and it even says the individual in which, I wish that little bar would go away, the mutation first appeared has even been identified. So I don't know much about this one. I just found it, but it would be very interesting to look up and to know if you're Italian, do you possibly have that in your blood vessels? Very cool. Okay, how about animals? We're animals, but you know what I mean. So camels, the Gobi Desert in Mongolia is where some camels live, and they can go 1 week without drinking water, but they can go several months without food. Okay, and why is this? It's because, without drinking water in several months if they eat food. So reverse that. I have to read a little bit more closely what I typed here. So why is that? Why can they go so long without water? So they don't store water in their humps. That's a fallacy. They store fat in their humps. And you'll see some camels, the humps will get smaller as their body uses it up, and then they have to replenish those stores over time. So this is because of the shape of their blood cells. Their cells aren't round like ours. They're elliptical, like elongated. And, when you get dehydrated, your blood thickens up. And when you drink enough water, it can flow very easily. Well, with camels, they can go a long time without water because of the shape of those blood vessels. And their blood vessels can still flow through, their blood can still flow through their blood vessels. For people, if our blood doesn't flow and it gets chunked up because there's not enough liquid, you're not getting nutrients and oxygen to your organs and you could die. So that's why you die of dehydration. So with these animals, their adaptation is a different shaped blood cells. Okay. And it says, and their blood volume does not drop when dehydrated, unlike humans. How about bats? They are the only mammal that can fly. I think that's very beneficial to be the only mammal that can fly. Hello, guys. They're so cute. So they even have, here's a video here, but you just can't hear the audio. But this is a bat's wing, and look, they have fingers. They have 5 fingers. 1, 2, 3, 4, 5. Just like our hands have 5 fingers. Unlike birds, birds don't have their anatomy, and their wings aren't like that. Okay, you can see, look, their arm, their elbow, their forearm, and their fingers. It's amazing. I love that cute little face. It's adorable. This bigger bats are fruit bats. I just want to feed him a little apple. Hi, baby. All right. So how about, this is coming to the end here. There's a really cool, kangaroo mouse called the kangaroo rat. Okay. It can actually go its entire life without ever drinking water, believe it or not. They can jump super high, 9 feet in one jump. And they don't sweat, they don't pant the way other animals do to keep cool. Because when you sweat, and pant, you're getting rid of water. So they don't do that. They get all of their moisture from seeds that they eat. They are perfectly adapted to desert life. So in the United States, we have the kangaroo rat, and in Africa, there's the if I'm going to pronounce this right, the jerboa. So, what if you could have any mutation? What would it be and why? And feel free to post that on Google Classroom if you want to. I know me personally, I wish I had wings, a tail, gills. Yeah, that would be pretty cool. Wings, tail, gills. Yeah. So I can fly, I can swim under and breathe underwater, and I can grab things with my tail. Anyway, all right. So that's all I have for you about mutations and how they can be beneficial, and help animals and people, in very beneficial ways to pass on their genetics. Join me back tomorrow. Have fun with the activity with the peppered moth. And then we're going to do another activity. Have a good one. CG out.